hope you're watching this after solving the problem. This is a relatively simple and standard problem. The goal is to use KVL and KCL equations for a circuit with elements with more than two terminals. We have a three-terminal element here. This could be a transistor or anything like that. And a four-terminal element. This could be a transformer or sensor, whatever. I can say that this circuit graph has 5 nodes and 5 meshes, including the outside mesh. I will explain it later. Hence, I can write 5 KCL and 5 KVL equations. To do that for KCLs, I'm naming the nodes as such. Name node 1, 2, 3, 4, and 5. You may consider a super node for node 5 and 4 as I shown here. Again, I can write KCL equations for these Gaussian closed surfaces. I can choose the arbitrary current for each branch as such. I1, I2, I3, I4, I5, 6, 7, 8. Note that these directions are arbitrary and will not change the final result. So for node 1, sum of all current entering the node, which are I4 and 7, equals the current leaving the node, which is I1. For node 2, again, I1 and I3 entering the node, I2 exits the node. So for node 3, I can write the same. For this super node here, those entering the node is I2, and the current leaving the node are I5, 4, 5, and 6. You may deduce that if you add up all 4 KCL equations for first KCL equation, you will get the 5th one. So 4 of them are independent and 5th one are a redundant equation. You may have seen this before, but let's see the same for KVL. Let's name the inside meshes as mesh number 1, mesh number 2, and the direction of meshes as such, mesh number 3, 4, and the outside mesh number 5, the opposite direction. And I'm naming the voltage across the two terminal elements as V1, V2, and V3. Again, arbitrary direction. This arbitrary direction is consistent with the current arbitrary direction. But for three terminal elements, I name the voltages across the terminal as V4, V5, V6 as such, and 7, 8, 9, and 10 as is shown here. Again, these are arbitrary. Inside mesh 1, I can write the KVL. Starting from here, minus V3 plus V5 plus V1 is 0. For mesh 2, V3 plus V2 plus V8 is 0. Same for mesh 3, 4, and for the outside mesh, I have V9 plus V6 is 0. You may think yes, there is no V9 or V6 in the above equations. These are 5 independent equations, but 4 of them are independent, and 5th one depend on the above ones, as V6 is not independent from V4 and V5. One may say that V6 always equals V4 minus V5, and Same for V9, that V9 equals minus V8 plus V7 minus V10. And this equation is not an extra equation in this KVL that I wrote here. Okay, hope you enjoyed and learned something.